Assalamu alaikum students. Today we start new lecture. The real line. Real number तो आप पहले पढ़ चुके हैं. Next we represent it on a real line. X and X dash is totally called real line. We represent the number 0 by the point O called the origin. O को हम क्या कहते हैं? Origin of the line. Let OA represent a unit length. O to A at real line is called a unit length according to the unit. Positive numbers are represented on the line by points to the right O and negative numbers by the point to the left. यानी कि ओरिजिन के राइट साइड पे पॉजिटिव नंबर हैं और लेफ्ट साइड पे नेगेटिव नंबर्स. It is easy to illustrate that all positive and negative rational numbers are represented on this line. Between 0 and 1 there are many infinite decimal numbers, and these are rational, also irrational, like 0.5 is a rational number between 0 and 1, and 0.523167 continue, not terminating, non-recurring is irrational number also on this line. So all the real lines represent on this line. Next, some important point about this real line. There is a 1-1 correspondence can be established between the point of a line and the real number, because place of 0 fixed on the line and place of 1 is fixed on the line. This is called the 1-1 correspondence. If x1 and x2 are the number corresponding to 2 points p1, p2, then the distance between p1 and p2 will be x1 minus x2 mod. These straight lines are called modulus, always represent positive number. To any real number there will be 1 only one point on the line. Same above definition, 1-1 correspondence between the line the above line is called real line. Real number say x corresponding to any point p of the line is called the coordinate. Line is called real line and the point is called coordinate of the point. Next, the real plane or coordinate plane. We know that Cartesian product of any two non-empty sets A and B denoted by A cross B, and it contains element like ordered pair xy, x belongs to A and y belongs to B. The member of the Cartesian product or ordered pairs. आपके पास दो सेट हैं नॉन एम्प्टी, अगर इनका कार्टेशियन प्रोडक्ट लें तो इसमें आपके पास बनते हैं पेयर्स x, y, जिसको बॉर्डर्ड पेयर कहते हैं. फर्स्ट एलिमेंट बिलोंग टू A एंड सेकेंड एलिमेंट बिलोंग्स टू B. द प्रोडक्ट और क्रॉस x, और you know R is a real number, where R is the set of real number, is called Cartesian plane. All the element of R cross R form a Cartesian plane by taking two perpendicular lines x dash ox and y dash oy as coordinate axes on a geometrical plane. Choosing a convenient unit of distance, element of R cross R can be represented on the plane in such a way that there is 1 correspondence between the element or of R cross R and point of the plane. इनमें भी 1 correspondence है. जैसे आप किसी मैप के ऊपर किसी को लोकेशन को आपने पॉइंट करना है तो मैप पे उसकी पोजीशन सेम होगी, फिक्स, दो जगह पे भी नहीं हो सकता. तो इसको हम कहते हैं कॉरस्पॉन्डेंस, 1 कॉरस्पॉन्डेंस. लाइक अ नंबर ordered pair 3 and 2. In first quadrant, x and x dash is horizontal line, x-axis, y and y dash vertical line, y-axis, and 3 and 2. In the first quadrant, x is 3, y is 2, -4 and 3. -4 x है और 3 जो है y है, और ये दोनों किस में है? सेकेंड क्वाड्रेंट, बिकॉज x इज नेगेटिव. Both are negative, -3, -4 in third quadrant, x positive 5, y negative -4 in fourth quadrant. The geometrical plane on which coordinate system has been specified is called the real plane. Same like if we plot point on a line is called real line, and we plot coordinate point ordered pairs is called real plane or coordinate plane. Every real plane contain a point of R cross R. If a point A of a coordinate plane corresponding to the ordered pair AB and A and B are called coordinate of A. A is called the x coordinate or abscissa. In ordered pair, first element A is called x coordinate or abscissa, and B is called y coordinate or ordinate. As we show the numbers in the previous slide, these numbers on the plane. So every ordered pair, there is one and only one point in the plane. Corresponding to every point in the plane, there is one and only one ordered pair. It means also developed a 1 correspondence. Next is complex number, the complex plane, correspondence between the element ordered pair of Cartesian plane and the complex number. There is also a 1 correspondence between the complex number and the real plane. Therefore, there is 1 correspondence between the point of the coordinate plane and the complex numbers. We can therefore represent complex number by point of coordinate plane. In this, represent every complex number will be represented by one and only one point of the coordinate plane, and every point of plane will represent one and only one complex number. The component of complex number will be the coordinate of the point represented. It is in this presentation the x-axis, the real axis is called real axis, and the y-axis is called imaginary axis. In complex plane, x-axis is called real axis and y-axis called is imaginary axis. The coordinate plane itself is called complex plane or z plane. The plane contain complex number is called complex plane or z plane. These are some important points for objective. Next is representation of complex number on the plane. The figure represents one or more complex number on the complex plane is called an organ diagram. This diagram is called organ diagram. Point on the axis represent the real number, whereas the point on the y-axis represent imaginary numbers. Just like point A, 3 minus 3 dot 3 plus 2 iota. 3 is a real number on x-axis and 2 imaginary number on y-axis. In C point, x is minus 2 and y is minus 1. Draw it again on a rough page. Next is modulus of a complex number. We know that complex number x plus iota y. Then x square plus y square. X means real part of complex number. Y means imaginary part of complex number. And square root of both is called modulus of the complex number. You can see a point A plus b iota or x plus iota y. We OM represent x, AM represent y, and this is a right angle triangle, and OA is a hypotenuse. We apply Pythagoras theorem, and OA become x square plus y square square root, modulus of a complex number. And this is also the distance of a complex number from the origin where both the line x-axis and y-axis intersect. Next is example. Find the modulus of different complex number. In first example, real part is x, imaginary part is y, then square of both these numbers, add them and taking square root. Here you have only a complex number, only imaginary number, then real number is a 0. Very easy. And this is a theorem, only statement. Modulus of minus z, z bar or minus z bar are always same. In second example, if we take a bar of a z and then again taking its bar, it becomes z. Product of z and z bar is equal to z magnitude square. z1 plus z2 whole bar is equal to z bar plus z2 bar. z1 over z2 whole bar is equal to z1 bar over z2 bar. And number 6, z1 z2 product, magnitude of its product is equal to the magnitude of their product. Next is last but very important, polar form of a complex number. If we have a complex number z is equal to x plus iota y, is called Cartesian form or rectangular form. And polar form, in polar form coordinate are r and theta. The relationship between polar form and complex and Cartesian form, x is equal to r cos theta and y is equal to r sin theta. And the formula between them is x is equal to r is equal to x square plus y square magnitude, or this is also called modulus of a complex number. And angle is equal to tan inverse y divided by x. For example, we have a complex number 1 plus iota square root 3. In this example, x is equal to 1 and y is equal to square root 3. Put these values in above formula r and theta. We get the value of r and theta. Just like that. And at the end we get the complex number like x is equal to r cos theta and r sin theta. R is equal to, we get 2 and theta is 60 degree. And then De Moivre's theorem, cos theta plus iota sin theta whole power n. This whole power multiplied by the angle and it becomes cos n theta plus iota sin n theta. And n is always an integer. Okay student, solve these examples and read it carefully, and if you have any problem contact with me. Thank you. Allah Hafiz.